All right, let's do problem number 1. You've had a little time to try it out. 1 over 2 plus 2 squared over 2 squared plus 3 squared over 2 to the third plus 4 to the second over 2 to the fourth plus dot, dot, dot. Take a look at this and go, okay, so the nth terms, this is the first term, second term, third term, fourth term. I would look at this and go, I'd put a little 2 up here and a little 1 there, right? So follow the pattern. And then I would say, well, this is just the nth term would be 1, 2, 3. So it'd be n to the second over 2 to the first, 2 to the second, 2 to the third. So it's 2 to the nth. Agreed? And then the n plus 1 term would be a little trickier. It's going to be n plus 1 squared over 2 to the n plus 1. So pausing there. So then I'm going to go, the ratio test would therefore be n plus 1 squared over 2n plus 1 all over the nth term, which would be 2 to the n over, whoops, is the n to the 2? I said it backwards, but I wrote it right. So this becomes, the top would become n squared plus 2n plus 1. I did FOIL that. Over n plus 1 times flip 2 over n squared, which becomes, simplifying, I got one more 2 on the bottom than the top. Everything else is pretty much as simple as it's going to get. So I got n squared plus 2n plus 1 all over 2n squared. So that's going to be my ratio. Then I'm going to take the limit as n approaches infinity of my ratio, which is n squared plus 2n plus 1 all over 2n squared. Divide by the highest power of n I find anywhere in here. Looks like 1 over n squared would do the job. That gives me the limit as n approaches infinity of 1 plus 2 over n plus 1 over n squared all over 2. Anything with a 0 in it goes away. I get 1/2. Is my ratio less than 1? It is indeed. Therefore, this is convergent. That's all I discovered. It's convergent. All right. Give a moment so we can pause this. Go ahead and try problem number 2. Should be good. Problem number 2. 0.006, 0.06 plus 0.6 plus dot, dot, dot. So this is my first term, my second term, my third term. Just my nth term. Ew. Well, in order to get from here, my ratio is 10. Get from here, my ratio is 10. Wait, it's just a geometric series, and its ratio is 10. Is it convergent or divergent? It's divergent. I'm done. Again, the ratio is equal to 10. That's going to happen at infinity, which also makes it divergent by definition. All right, cool. Okay, getting a minute here to pause this. Go ahead and try problem number 3. Problem number 3. All right, problem number 3. Here we go. Problem number 3. Here we go. Okay, so I take a look at this and go, all right, well, I need a pattern. It looks like I got a separate pattern top and bottom, so I'm going to call this my first term, my second term, and my third term. I have to figure out what my nth term is. So the bottom is multiplying 1 times 2 times 3. So the bottom is going to be 3 factorial. And this is 4 factorial, and this is 5 factorial. So the bottom looks like it's going to be just n plus 2 factorial. Again, how did I get that? When I put in a 1, I should get 3 factorial. 2, I should get 4 factorial. 3, I need to get 5 factorial. Therefore, it must be n plus 2 factorial. The top, what am I doing? multiplying by 2 each time, right? That makes it geometric. Geometric means that I'm going to use this is going to be, to find my nth term, I'm going to be talking about a1 r to the n minus 1, agreed? So I'm going to drop this down one more time. I'm going to go a1, so 4, times a ratio which multiply by 2, right? 4 times 2 is 8, times 2 is 16. That's 2 to the n minus 1 all over n plus 2 factorial. So the next term would be 4. 2 to the n, which would be 1 more, n plus 3 factorial. So now I'm going to do my ratio test. So I'm going to find my ratio. My ratio would be 4 times 2 to the n over n plus 3 factorial times flip n plus 2 factorial over 4 to the 2n minus 1. Trying to simplify this. Got 4s, those cancel out. I got one more 2 on the top and the bottom, so I got 2 times n plus 2 factorial over n plus 3 factorial. Now, how do I deal with factorials? The bottom has one more factorial than the top, right? So if I was going to talk about, let's say, 4 factorial over 5 factorial, that would be 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. Every pause, make sure you can see this. So 4 factorial will be 4 times 3 times 2 times 1. 5 factorial will be 5 times 4 times 3 times 2 times 1. Notice what happens. Bang, 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 bang. I get 1/5. If I were to do 5 factorial over 6 factorial, same sort of thing would happen. 5 times 4 times 3 times 2 times 1 over 6 times 5 times 4 times 3 times 2 times 1. Everything cancels out but the very first term. So, in this case, kind of smushy here, but we'll try to do this. I have one more term than the bottom and the top, so n plus 3 would be left over. Everything else would cancel out, agreed? So if I go to take the limit as n approaches infinity of 2 over n plus 3, well, if I put infinity in the bottom, this thing's going to 0. And if it's going to 0, this is convergent. Good deal? Alrighty then. Okay, try number 4. Try number 4. Try number 4. Pausing right now so you get a chance to do a problem or two. Number 4. Number 4. 5 plus 5 over 3 to the third plus 5 over 5 to the third plus 5 over 7 to the third. This looks weird, so I'm going to write it as 1 to the third. Right? Make the matter. So the nth term. So I take a look at the top. Top is just 5. That's easy enough. The bottom's a little trickier. Something to the third power. It's 1, 3, 5, 7. That's arithmetic. So the arithmetic would be a1 plus n minus 1 times the common difference. So first term is 1, n minus 1. The difference is 2. I'm going to go ahead and simplify this just to make my life a little better. So 1 plus 2n minus 2, or 2n minus 1. So this becomes 2n minus 1 cubed. Ew. That's going to hurt us later. So then the next term would be 5 over 2 parentheses n plus 1, n parentheses minus 1 cubed. Love it. So far so good. So then the ratio test would be 5 over, I'm going to have to simplify that, so I got 2n plus 2 minus 1 to the third times, flip, I've got 2n minus 1 to the third over 5. 5's cancel out. I need to work on this ugly thing here. So I start to work on my factoring because that's fun too. And I've got 4n minus 4n squared minus 4n plus 1 all over 4n squared plus 4n plus 1 times, I've just got a 2n minus 1 on top, and I have a 2n minus plus 1 on the bottom. I start to work the problem some more. I got 8n cubed minus 8n squared plus 2n minus 4n squared plus 4n minus 1 all over, and on the bottom I have 8n cubed plus 8n squared plus 2n plus 4n squared plus 4n plus 1. Simplifying further, 8n cubed minus 12n squared plus 6n minus 1 all over 8n cubed plus 12n squared plus 6n plus 1. Woo! So now I'm going to divide by the highest power of n. I find anywhere in the problem, which is 1 over n cubed, 1 over n cubed. I get 8 minus 12 over n plus 6 over n squared minus 1 over n cubed all over 8 plus 12 over n plus 6 over n squared plus 1 over n cubed. Now look at this. Anything with the n on the bottom goes away. I get 8 over 8, which is 1. Can't tell. Done. All right, setting up for a pause, and then you can do number 5. Number 5. All right, number 5. If you recognize the geometric, you can save yourself some steps, but if you don't, the nth term, well, this is 1 over 3 to the 0, 1 over 3 to the 1, 1 over 3 to the second, 1 over 3 to the third, plus dot, dot, dot. So the nth term would be 1 over 3 to the n, and the nth plus 1 term would be 1 over 3 to the n plus 1. Set up my ratio test. My ratio would be 1 over 3 to the n plus 1 times, flip, 3 to the n over 1. I got one more 3 in the bottom than top. My ratio is 1/3. There's no n in it, so the limit would also be 1/3. And it is, in fact, convergent. All right, have fun with the rest of them.